Hi, this is Mrs. Basden, and in this screencast we're going to learn how to name ionic compounds that have single charge metals. So again, just as a review here, an ionic compound is something that has a metal and a nonmetal. So when you have a substance that has a metal and a nonmetal and you're looking to give it its chemical name, these are the rules that we're going to follow. So again, an ionic compound, like we just said, is a metal and a nonmetal. When we name these, the cation is named first, the anion is named second. And if you remember, the cation was the positive ion, or the one towards the left on the periodic table. The anion is the negative ion, and that's the one more towards the right. When you name the cation, that's just named with the name of the element. So for example, Na plus is just called the sodium ion. The anion is named by taking the root, dropping the ending, and adding IDE. So Cl minus is called the chloride ion. So Cl by itself is called chlorine. When it's Cl minus, when it has a charge, then you drop the ending and add IDE. Here's some examples. So you can see off to or on the left here, all of these positive ions, the name of the ion is the exact same as the name of the element by itself. Now over on the right, all the negative ions or the anions, you can see the endings have all been dropped and IDE has been put in its place. So let's look at some examples here. NaI, if you're going to name that compound, you name the first part of it, the positive part, just by the name of the elements, and then the second part of it, we drop the ending, we add IDE. So NaI, the name of that, is called sodium iodide. Our next example over here, calcium, the plus ion or the cation is named calcium, just like the element by itself. The negative ion or the anion has the ending dropped, IDE on the end, so this would be called calcium oxide. Okay, so let's just look at some example problems here. Let me go ahead and put them all on the screen and then we'll go through them. So again, this is probably the easiest of all the different things that we're going to look at to name. And again, this only works for ionic compounds that have what are called single charge metals. So the things that we're working with right now are just things that can only have one possible charge. In our next lesson, we'll talk about how you know the difference between something that has a multiple charge and something that doesn't. So for now, we're going to assume that these are all, which they are, single charge metals. So our first one here, NaCl, all we have to do is name of the first, sodium, IDE on the second, chloride. So NaCl is called sodium chloride. Ki is potassium iodide. So iodine, drop the ending, add IDE. CaS, calcium sulfide. CSBr, cesium bromide. MgO, magnesium oxide. So again, name of the first element, IDE on the second. So our next slide here has some practice problems. So if you feel comfortable with this, go ahead and stop the screencast for a couple minutes, do the examples, and then come back and check. Okay, so our first one, CSF, would be cesium fluoride. So again, drop the ending, add IDE. AlCl3, aluminum chloride. Next one, MgI2, magnesium iodide. And my last one, rubidium oxide. So again, name of the first, IDE on the second. Okay, the last thing we're going to look at in this screencast is how to write formulas from the names. So this is kind of working in the opposite direction. Just now we used the names and went to the formulas. Now we're going to look at writing the formulas from the names. So when you do these, all we're going to do is go back and use those charges that we talked about on the very first slide. Then we're going to look up the charges for each one of these components, and then we're going to crisscross them, which will give the balanced charge that this compound requires to be stable. So lithium is Li. Lithium is in group 1, if you look back at your periodic table, so everything in group 1 has a +1 charge. Bromide comes from bromine, and bromine is in group 17, so it's Br with a -1 charge. So once you have the charges there, then what you're going to do is crisscross those down. So this one comes down to bromine, this one goes down to lithium. When you bring those down, you drop the charges. So this would be Li1Br1, but like we've talked about before, we don't need to write that, so this compound would simply be LiBr. Okay, so let's look at our next one, calcium chloride. Calcium is a +2 because it's in group 2. Chloride comes from chlorine, which is a -1. Then we're going to cross our charges, and then when we drop them down, we're going to lose the plus and minus, and this was a -1 up here, so we end up with CaCl2. Okay, my last one here, aluminum oxide. Aluminum is a +3 because it's in group 13. Oxygen, -2. Cross my charges here, and I end up with Al2O3. Okay, so on my next slide, I have some practice problems. So again, if you're comfortable with this, go ahead and stop the screencast for a minute, do some practice, and then come back and check. Okay, so potassium nitride. Potassium is K+. Nitride is nitrogen, which is N-3. Cross those charges down, so I end up with K3N. Next example, calcium oxide. Calcium's a +2, oxygen's a -2. Crisscross my charges, and I end up with Ca2O2. And for these ionic compounds, you can put this in the reduced form, so those 2's will cancel each other out, so I can just write CaO. Last one, beryllium iodide. Beryllium is Be, which is a +2, it's in group 2. Iodide is in group 17, so it's a -1. Crisscross my charges, and I end up with Be1, which I don't need to write, I2.